This video is on Compton scattering. Question 1. Describe the Compton effects. A high-energy photon like an X-ray or gamma ray can scatter off an electron at rest. The photon will lose energy. This experiment showed that a photon behaves as a particle. The photon will lose energy and the electron will gain kinetic energy after the collision. So we have this equation here. So lambda f is the final wavelength of the photon. Lambda initial is the initial wavelength of the photon. Delta lambda is the change in wavelength of the photon. We know h is Planck's constant, m sub e is the mass of the electron, c is the speed of light. And theta is the scattering angle of the photon in degrees. Question 2. An incoming photon with a wavelength of 6 times 10 to the minus 1. It's actually times 10 to the minus 10. It didn't save correctly. Strikes an electron at rest. The photon rebounds at an angle of 120 degrees to its original direction. Determine the speed and wavelength of the photon after the collision. So the final speed of the photon is the speed of light in a vacuum. Okay, so let's take a look at this equation. They gave us the initial wavelength of the photon, which is 6 times 10 to the minus 10. We know h, we know m sub e, we know c. These are constants. And we know theta is 120 degrees. So plugging everything into the equation, solving for lambda sub f, we get 3.64 times 10 to the minus 12 meters. So in this case, the wavelength decreased. Question 3 and 4. These are very important. State 2 experiments in which light behaves as a wave. Do not explain the experiments, just state them. Diffraction and polarization. Question 4. State 2 experiments in which light behaves as a particle. Do not explain the experiments, just state them. The photoelectric effect and the Compton effect.